Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized, easy-to-digest pieces.
Today we're talking about a phenomenon in AI that's both fascinating and slightly terrifying. Imagine you ask a friend who's a huge art expert to describe a painting you just bought. You send them a text, but you forget to attach the picture.
And what if your friend, instead of saying, "you forgot the picture," just starts describing a magnificent, detailed painting of a pirate ship on a stormy sea, completely from their imagination?
Exactly. That's kind of what some of the most advanced AI models are doing. This paper calls it a mirage, and it's a huge problem, especially when we're relying on these systems for important tasks.
The paper is titled Detect Before You Leap: Mirage Detection in Vision Language Models. It's from researchers at Indiana University, Indianapolis, and Bangladesh University of Engineering and Technology, and it tackles this exact problem head-on.
So let's set the stage. We're talking about vision language models, or VLMs. These are the AIs you see that can look at an image and answer questions about it. Think of asking an AI what breed a dog is from a photo, or to describe a scene.
But here is where the mirage comes in. The paper points out that sometimes these models will give a confident, detailed answer even if the image has nothing to do with the question, or even if the image is completely blank.
And the example they use is a serious one. Imagine a doctor using an AI assistant. They ask, "Is there an aortic aneurysm in the CT scan?" But they accidentally upload a picture of a landscape. The mirage problem is when the AI confidently replies, "Yes, the aneurysm is located in the upper quadrant."
Yikes, that's not just a funny mistake, it could be incredibly dangerous. The AI is so keen to answer the question based on its vast text knowledge that it completely ignores the fact that the visual evidence doesn't support its answer at all.
So the researchers said, we need a bouncer. We need a system that stands at the door, looks at the image and the question, and decides if the AI should even be allowed to answer. That's the detect before you leap idea.
And they built a multi-stage pipeline to do just that. It's like a bouncer with a very thorough checklist. The first step is super simple. Check the ID.
This is stage 1, blank and noise detection. The system just looks at the basic pixel statistics of the image. Is it a pure white screen? Is it just random static? If so, it gets rejected immediately. The AI is told to abstain and say something like, "I cannot answer based on the given image."
Okay, so that gets rid of the easy cases. But what about the landscape photo? Or my personal favorite, a picture of a cat when you're asking about a medical scan?
That's where the next stages come in. The system first tries to figure out what kind of image it's looking at. Is it a medical image, a document, or a natural photograph? This helps it know what to expect. But the real magic is in stage 3.
This is the core of the paper, a method they call TC-LIA, which stands for Text-Conditioned Layer-Wise Internal Alignment. It sounds complicated, but the idea behind it is brilliant.
It is. To understand it, you need to know that when an AI sees an image, it processes it through many layers. The first few layers might only see basic things like edges and colors. As you go deeper, the layers start to recognize more complex concepts like shapes, objects, and eventually the entire scene.
Right, so what this TC-LIA method does is it peeks inside the AI's brain at every single one of those layers, and at each layer it asks a simple question. How much does the part of the image you're looking at right now align with the text of my question?
And this is where they spot the difference between a good pair and a mirage. If you give the AI a real CT scan and ask about an aneurysm, in the early layers, the alignment might be weak. But as it gets to the deeper layers, specific parts of the image will start to strongly align with the question. You see a connection being formed.
The paper has these great graphs that show this. For a related image and question, the alignment score starts low and then shoots up in the later layers. It's like a detective finding more and more clues and becoming more confident.
But for an unrelated image, like the cat photo, that line stays flat or just wiggles around randomly. The AI is looking, but it's not finding any connection between the visual information and the words in the question. The detective is coming up empty.
So the system measures this trajectory. It looks at the final alignment score, but also the gain, how much that score increased from early to late layers, and the overall slope of that line. It's a way of measuring if the AI had a eureka moment or if it was just confused the whole time.
And they don't stop there. They combine this clever layer peaking technique with a few other signals. They even ask the VLM itself to make a quick judgment. Do you think this image is related, unrelated, or blank?
So they take everything, the basic pixel check, the TC Leah scores, and the AI's own self-assessment, and feed it all into one final decider. This ensemble classifier makes the final call. Yes, this is a legitimate request. Generate an answer. Or, no, this is a mirage. Abstain.
So the big question is, does this bouncer actually work?
It works incredibly well. The paper tested it on a bunch of different vision language models, and they found that without their system, some models had mirage rates as high as 66%. That means 2/3 of the time they were given an unrelated or blank image, they would just make up a confident answer.
Wow, and with the detect before you leap system in place?
They reduced that mirage rate to around 2 to 3%. That is a massive reduction in dangerous, unsupported answers. It successfully catches the mirages before they happen, while still letting the valid answers through.
That's fantastic. It really shows that for AI to be truly useful and safe, it needs more than just intelligence. It needs a kind of self-awareness. It needs to know what it doesn't know, or in this case, what it can't see.
Exactly. This isn't about making the AI smarter at answering. It's about making it wiser about when to answer. It's a critical safety layer, especially as we start using these tools in high-stakes fields like medicine, finance, and legal document analysis. You need the AI to be grounded in reality, in the evidence it's given.
So, the next time you see an AI give an amazing answer about an image, there might just be a very sophisticated bouncer behind the scenes, making sure it wasn't about to describe a pirate ship in a picture of a cat.
And that's a very reassuring thought. That's all the time we have for today. Thanks for tuning in to Daily Papers.